Hello everyone, my name is AaronTheSloth and welcome back to another episode of the Level Up series. So far, we've spent several episodes talking about what happens inside of a computer. We've covered CPUs, we've covered RAM, motherboards, storage devices, and how all those components work together. But here's the problem. Even the fastest computer in the world becomes pretty limited if it can't communicate with anything else. No internet, no email, no cloud storage, no printers, no shared files, no online gaming. Networking is what allows computers and devices to communicate with one another, and understanding networking fundamentals is one of the most important skills that you'll develop in IT. Whether you're aiming for a help desk position, desktop support, system administration, cybersecurity, or cloud engineering, networking knowledge follows you throughout your entire career. Today, we're going to build that foundation by discussing what networks are, LANs and WANs, IPv4 addressing, DHCP, DNS, common networking devices, TCP and UDP, and finally ports and protocols. We'll finish with several performance-based questions and a troubleshooting challenge similar to what you may encounter during a job interview. Let's get started. So what is a network? At its core, a network is simply two or more devices connected together for the purpose of sharing information. That's it. A network can be incredibly small or incredibly large. For example, a laptop connected to a printer over Wi-Fi is a network. A home with multiple devices connected to a router is a network. A corporation with offices across multiple countries is a network. The internet itself is a massive network made up of countless smaller networks connected together. So think about your house for a second. You may have a desktop computer, a gaming console, smart TVs, smartphones, tablets, security cameras, or even a smart thermostat. All of these devices communicate using networking technologies. And as IT professionals, it's our job often making sure that these devices can't communicate properly. And when networking fails, users usually don't care why. They simply tell us, my internet isn't working. And it's our job to figure out what's broken. So let's throw in a CompTIA style question. A user wants to print a document from their laptop to a wireless printer in the same home. What allows those devices to communicate? CMOS, BIOS, network, or power supply? The answer is C, a network. Now let's talk about a local area network versus a wide area network. Not all networks are the same size. One of the most important distinctions that you'll learn is the difference between a LAN and a WAN. A local area network is a network that exists within a relatively small geographic area. Some examples include a house, a school, an office building, or a hospital. LANs are generally faster, easier to manage, and under local control. If you've ever connected your gaming PC to your home router, you've used a LAN. If you've worked in an office and connected to company resources, you've also used a LAN. Now, what's a wide area network? Well, a WAN connects multiple LANs together. So think about a company that has offices in Dallas, Houston, and Austin. Each individual office has its own LAN, and the connections between those offices create a WAN. The largest WAN in existence is the internet. A simple way to remember this is think of a LAN as your neighborhood, and a WAN is the highway that connects multiple neighborhoods together. Question 2. A company has offices located throughout Texas, connected through dedicated circuits. What type of network is being used? A PAN, a LAN, a WAN, or a SAN? The answer is C, a WAN. So again, when it comes to all CompTIA style questions, you may want to know what the other answer choices are and why they are incorrect. So let's quickly go over a PAN. A PAN is a personal area network. You can think of your Bluetooth devices interconnecting. We know what a LAN is. A LAN is your home network, so all of your desktops and laptops and gaming consoles connected together. We know what a WAN is, a wide area network connecting multiple LANs together. Now, a SAN is a storage area network, which we may go into more detail in a later video. Just know that a SAN interconnects different storage devices together over a network connection. Now let's try to understand IPv4 addressing. Imagine trying to mail a package without knowing the recipient's address. It simply wouldn't arrive. Networks work the same way. Every device on a network requires an address, and this address is called an IP address. An example of an IP address is 192.168.1.100. An IP address uniquely identifies devices on a network so information knows where to go, or rather a router knows where to send the information. When you visit a website, send an email, or connect to a printer, your device uses IP addresses behind the scenes. Now let's talk about public versus private IP addresses. So let's go over private IP address ranges that are used inside local networks. Common private IP ranges include Class A range, which is 10.0.0.0 all the way to 10.255.255.255. Class B private IP ranges include 172.16.0.0 all the way to 172.31.255.255. A Class C private IP address range would be 192.168.0.0 all the way to 192.168.255.255. Most home networks use 192.168.x.x. Examples where you would use a Class A private IP address range would be if you have a large enterprise with, let's say, 10,000 plus devices. You would use a Class A private IP address range so that all devices on your network would definitely have a unique IP address. A Class B private IP address range would be used in small to medium-sized businesses where you would likely have thousands of devices. Regardless, public IP addresses are assigned by your internet service provider and are visible to the outside world. You can think of your public IP as your home's street address. Now, think about private IPs as the room numbers inside of your house. Question 3. Which address below is considered private? 8.8.8.8, 192.168.1.50, 172.50.10.5, 64.233.177.113. The answer is B, 192.168.1.50. And also note that 8.8.8.8 is actually Google's public DNS server. So if you're ever having issues on your home PC, let's say connecting to Facebook, you could try changing the default DNS address if it were 4.4.4.4, which is also Google's public DNS. Change it to 8.8.8.8 and you may have better connections. Might. Take that with a grain of salt. Moving on, DHCP. Now imagine you're an IT technician and you're deploying 300, 3,000 laptops. Would you want to manually assign each laptop its own IP address, subnet mask, default gateway, and DNS server? I sure as heck wouldn't. To every single device? Yeah, no, I'm good. This is why DHCP exists. DHCP stands for Dynamic Host Configuration Protocol. Its job is to automatically provide network settings to devices. So when a device joins the network, it basically says, can somebody give me an IP address? And the DHCP server responds with the necessary information. Most home routers contain built-in DHCP servers, and in enterprise environments, the DHCP server is often hosted on a dedicated Windows server. One of the most common troubleshooting indicators you'll encounter is an address beginning with 169.254.x.x. This is called an APIPA address, and when you see it, your brain should immediately think this device couldn't contact DHCP. CompTIA loves asking APIPA questions, so definitely remember it. Question 4. A computer receives an address of 169.254.44.20. What is most likely the cause? A DNS failure, a DHCP failure, an SMTP failure, or a switch failure? The answer is B, a DHCP failure. So we know that with a DNS failure, it would likely be that answer choice if the question asked why a user is unable to connect to Facebook.com, but when you ping Facebook.com and get its IP address and you put that into a web browser, then you can connect to Facebook. That's how you would know you have a DNS failure. An SMTP failure would simply mean that the computer was unable to send email for whatever reason. And then a switch failure would simply be an indicator of if a computer cannot interconnect with other computers. Let's say a user's machine couldn't print for whatever reason, as in the user's machine couldn't reach the network printer. So what is DNS? Humans prefer names, computers prefer numbers. You remember Google.com. The computer needs an IP address. DNS stands for Domain Name System. Its job is translating names into IP addresses. You could think of DNS as the internet's phone book. A real-world troubleshooting example. A user tells you the internet is down. You investigate and discover that they can ping 8.8.8.8, but they can't browse websites. The network itself isn't what's broken. DNS is what's broken. This is why DNS issues often look like internet outages, and as an IT technician, DNS should always be on your troubleshooting checklist. Question 5. What's the primary purpose of DNS? Assign IP addresses, translate names into IP addresses, encrypt traffic, or route packets. The answer is B. Translate names into IP addresses. So we know with A, assigning IP addresses is the purpose of a DHCP server. To encrypt traffic is the firewall's job. And to route packets is your router's job. We'll go into those devices later. Now let's talk about common network devices. These will be different forms of equipment that you'll encounter most frequently. A router connects different networks together, most commonly your home network connecting to the internet. So you can think of routers as traffic directors deciding where data should go. A switch connects devices within the same network. Businesses often have dozens or even hundreds of devices, all connected through switches. If your office suddenly adds 20 new employees, well, a switch is what allows those devices to connect to the existing network. A wireless access point provides wireless connectivity. Without an access point, wireless devices would have no way to join the network. A modem connects your network to your internet service provider. Fiber, cable, and DSL connections all rely on modem technologies. Question 6. Which device primarily connects devices together within the same local network? A router, a switch, a modem, or firewall? The most likely answer choice here is B, a switch. Now, a router can have built-in switch capabilities, but when we're talking about a business, they would most likely use a switch, and then a router is what actually transacts the internet traffic, whereas a switch is what connects these devices together. And then we know a modem is what allows your internet to reach the internet service provider. And then we also know that a firewall can intercept traffic and allow or disallow traffic based off of ports and protocols. Now let's talk about TCP versus UDP. Both TCP and UDP are known as transport protocols, but they prioritize different things. TCP prioritizes reliability. So if data is lost, TCP is what requests that retransmission of data. So imagine transferring payroll records. Would you want 70% of the file, or would you want 100%? Obviously you want 100% of the file, and that's what TCP does. Some examples of TCP are web browsing, email, and file transfers. Now, UDP, on the other hand, prioritizes speed. So if packets are lost, it usually doesn't stop and ask for retransmission. So think about when you're streaming Netflix. If one frame gets lost, would you rather the entire movie pause repeatedly, or would you rather just continue watching at a lower quality? Most streaming services opt for speed, and that's UDP. Examples of UDP are streaming, or online gaming, or voice over IP. So question 7, which protocol is typically preferred for online gaming? TCP, UDP, SMTP, or DNS? The answer is UDP. Again, TCP is a connection-oriented protocol, which is more likely used with email or file transfers, and then SMTP is simply email, and DNS just has to do with translating names into IP addresses so that computers can know what they're connecting to. Now let's talk about ports and protocols. Think of an IP address like a hotel. The IP address gets you into the building, but the port number gets you to the correct room. Different services listen on different ports. Some examples include HTTP connects to port 80, HTTPS, or Hypertext Transfer Protocol Secured, connects to port 443. DNS connects to port 53, SMTP connects to port 25, RDP connects to port 3389, and SSH connects to port 22. You'll see these ports and protocols all throughout your IT career. One of the best tips or pieces of advice that I can give you guys for whenever you go and take any CompTIA exam, if you are going to a testing center and you know beforehand that the testing center gives you, say, a piece of notebook paper or a laminate sheet of paper, which in my case a lot of testing centers did, then you'll know before you start your exam, you can memorize, let's say, a cheat sheet, and it has all the information laid out in a standardized format for you. You can word vomit all over that page before you hit start on your exam. This will let you min-max the amount of time that you have on your test so that when you come across one of these questions that asks for what ports and protocols match to the numbers and the services, you can easily reference that cheat sheet that you just verbal vomited onto your laminate sheet of paper. Now, I will say if you take your tests remotely, which I do sometimes, more likely than not, you're not going to get that sheet of notebook paper. But I have had some proctors actually allow me to use a sheet of paper as long as I prove that the paper has no writing on it prior to starting my exam. Question 8. A user cannot establish a secure connection to a website. Which port should you think about immediately? Port 80, port 53, port 443, or port 25? The answer is C, port 443. And the reason why we know that is because the question asks specifically for a secure connection to a website. And we know that port 443 uses HTTPS, or Hypertext Transfer Protocol Secured. If the question asked for just a connection to a website, but specifically called out it doesn't have to be secure, or the user doesn't want the connection to be secure, we would know that the answer is port 80. If the question asks that the user is unable to connect to a website, but can use the website's IP address to connect, we would know that the answer is port 53. If the question simply asks that the user cannot send email, well, out of all the answer choices, port 25 is the only available answer choice that has to do with transferring email. Now let's look at some performance-based questions. CompTIA will likely give you a scenario, but in this performance-based question, we're simply asked to build the network. So you're given some common networking devices here, and it wants you to arrange these devices into the correct topology to support internet access, wired desktops, and wireless laptops. So the modem connects to the internet service provider, the router connects to the modem, the router connects to the switch, or rather your wireless access point connects to a router, and the wireless access point is what connects to the wireless laptops. Now let's move on to performance-based question number 2. Diagnose the workstation. In these types of questions, CompTIA will likely give a scenario for what it is that they want you to accomplish with this lab environment, but let's review the ipconfig output. Here we can identify the root cause and identify maybe the first 3 troubleshooting steps. Sometimes CompTIA just wants you to simply answer a question or put answer choices in terms of least to greatest in how effective the troubleshooting steps would be. Or sometimes they just give you a lab environment and you're just meant to figure it out. As long as you know the basics for diagnosing a workstation and making sure that the workstation connects to the DHCP server and or the DNS server, being able to identify the issue of the workstation is the ultimate goal of these performance-based questions. Now let's move on to performance-based question number 3, a port matching exercise. This is more likely something you can see on the exam, where you're given multiple ports and protocols and you're just meant to match the terms to their correct definition. So if you're given HTTPS, you would connect that to 443, DNS 53, SMTP 25, SSH 21, RDP 3389. I would memorize from 1 to 1,000, or just Google the most common ports and protocols. I think CompTIA has a list of the most common ports and protocols, so as long as you memorize those, or at least memorize a good majority of them, the other ones should fall into place a lot easier. And if you miss a couple, I'm pretty sure CompTIA gives somewhat partial credit for some answer choices, so don't be afraid to get things wrong. Ultimately, you're given a time limit on the test, so just answer to the best of your ability and then move on. And if you have time at the end of your test, then go back and start troubleshooting. Because if you waste too much time on, let's say, question 10, and you've still got 80 more questions to go, you're going to run out of time. And all those other answer choices that are blank will be counted as a big fat 0. Now let's do an interview challenge. A user reports, I can browse websites, but Outlook won't send email. Now I'm going to pause the video here and I want you to try to walk through any sort of troubleshooting process that you can, and then I will give you some expected discussion. So a nice little step-by-step that I found when it comes to a user who says that they can browse websites but they can't send email. First, you would verify their internet connectivity. Next up, test their DNS settings. Next up, that I would verify SMTP settings. Next, I would review firewall restrictions, because it could be the Windows firewall that could be causing issues. Next, I would test their mail server availability, so maybe there's something wrong with the internal mail server. Finally, I would review their Outlook configuration. Maybe something's messed up with that. Just note this, good technicians don't jump straight to answers. They gather evidence first and then eliminate possibilities. And as long as you give an interviewer these types of discussion points or gathering evidence points, I promise you, you will knock your interview out of the park. When it comes to answering some interview questions, most interviewers don't expect you to know 100% every little question that they're going to ask. They want to understand you as a technician. They want to understand your troubleshooting process. They want to understand where you stand currently in your career. So when you apply to a help desk position job, if you can't answer a single question, that's okay. They want people who are green and ready to learn. So as long as you show your willingness to learn and your willingness to work well with others, that's ultimately all that they're looking for. Now, I'm not going to come out and say that every single interviewer is only going to care if you work well with others. Some really need you to be a top-notch, top 5% of your class when it comes to a job role. And that's okay. We're not meant to work in every single environment. Sometimes it's going to take a few interviews for you to find that perfect role for you. But sometimes interviewers are just looking to see if you're a culture fit rather than a technology expert fit. So don't stress if you don't do well in an interview. You never know, maybe you will end up getting a job offer. Just do your best and remain confident in everything that you say or do during an interview. Today, we built the foundation for networking by covering things like networks, LANs and WANs, IPv4 addressing, DHCP, DNS, network devices, TCP and UDP, and ports and protocols. In the next episode, we'll move on to wireless networking, Wi-Fi standards, Bluetooth, mobile technologies, and wireless troubleshooting. Thank you so much for watching. If you found this video helpful, consider subscribing. Give the video a like. It really helps my channel. Seriously, it does. In the meantime, keep leveling up, keep building those skills. I'll see you all in the next episode.